Good morning, students. Exercise 7.1, 24th problem. The problem is regarding just a matrix multiplication. You see that a shopkeeper in a nuts and spices shop makes gift packs of cashew nuts, raisins and almonds. Pack 1 contains 100 gram of cashew nut, 100 gram of raisins and 50 gram of almonds. Pack 2 contains 200 gram of cashew nuts, 100 gram of raisins and 100 gram of almonds. Pack 3 contains 250 gram of cashew nuts, 250 gram of raisins and 150 gram of almonds. Okay, so here the cost of 50 gram of cashew nut is 50 rupees, 50 gram of raisin is 10 rupees and 50 gram of almond is 60 rupees. Then what is the cost of each gift pack? Okay, here the pack 1, pack 2, pack 3, the amount of cashew nut, raisins and almonds are given. In the next one, for 50 gram of cashew nut, 50 gram of raisin and 50 gram of almonds, the cost is given. Okay, so we have to using matrices, we can find the solution of this problem. Okay, so if you use matrix, first I am going to write the cost matrix. Okay, so the cost matrix, if I write row matrix, that is 1 row and 3 columns. Okay, so 50, it is a rupees, 50 rupees, 10 rupees and 60 rupees, because each one, see the 50 rupees is the cost of 50 gram cashew nut and 10 rupees is the cost of 50 gram raisins and 60 rupees is the cost of 50 gram almonds. So therefore here I have written the rupees, that is the amount. Okay, so the cost matrix is 50, 10, 60, everything for 50 grams. Okay, so next one I am going to write the nuts and spices matrix, that is called as B. Okay, so here you see that a pack 1 I am going to write as a column. Okay, so pack 2 and the second column, pack 3 and the third column. Okay, you see that here in the pack 1 you are having 100 gram of cashew nuts. Okay, here the rupees are in terms of 50 gram. So 100 grams, how it will be converted? It is 2. Okay, so 50 grams is 1, means 100 gram is 2. And 100 gram of raisins. Okay, 100 gram of raisins. What is it? That's also 2. Okay, and 50 gram of almond. So 50 gram will take it as 1. Okay, in the same way, come to the fact to 200 grams. 200 grams means 50 gram is 1, means 200 gram is 4. So here it is 4. And 100 gram of raisin. 100 gram of raisin is 2. And 100 gram of almonds is 2. Okay, in the same way, pack 3. 250 gram of cashew nuts. So it is 5. Okay, and 250 gram of raisins. That also 5. And 150 gram of almonds. So that can be written as 3. So you see that this is the first row, 3 columns, and here is a third 3 rows and 3 columns. So the number of columns of the first matrix should be equal to the number of rows of the second matrix. So we can find AB. So we have to multiply. So take the first row, multiply with the first column. So if you have written the cost matrix as a row matrix, so the pack 1 has to be written as a column. Then only we can find the cost of each pack. So 50 into 2, that is 100, where 10 into 2 is 20 and 60 into 1 is 60. So first row, second column. So it is 200 plus 20 plus 120. And the next one, the first row, third column. So it is 250 plus 10 into 5 is 50 plus 60 into 3 is 180. So when you add, you will get 180, 340, 480. So it is the cost of first pack, and this is the cost of second pack, and this is the cost of third pack. Okay, so I have taken cost matrix A as row matrix. So if you can take it as a column matrix means, you see that it's a 3 rows and 1 column. So it can't be multiplied with A matrix. So I have taken the nut matrix as A matrix. It has 3 rows and 3 columns. Then the cost matrix, if you take column matrix, you have to take it as a B matrix. So the number of columns of the first matrix is equal to the number of rows of the second matrix. In this way also you can do. So here, see the pack 1, here it is written as a column. Here you have to written as a row. Okay, so whichever is easy, so you have to take it. Okay, in the same way you will have one example, you have to go through that. So next I'll come to the exercise 7.2. In the previous class we have discussed about how to evaluate the determinant. So it's a 2 by 2 determinant, means you have to cross multiply the main diagonal, in between you have to write minus and multiply the sub-diagonal elements. If it is a 3 by 3 determinant, means expanding by any one row or any one column, using cofactors we can find the value of the determinant. So for that only we are going to see now. Exercise 7.2, 18th problem. If lambda is equal to minus 2, determine the value of this determinant. You see that determinant has to be written within the vertical lines. If we have the entries are written within the vertical lines only, we can find the value. The entries are enclosed with the square bracket. It's a matrix, it's a arrangement. We can't find value for that. If the entries are written only in the vertical line only, we can find the value of it. Okay, so I'll consider the determinant. In that I have to substitute lambda is equal to minus 2. So wherever you are having lambda, you have to substitute minus 2. And here minus 2 the whole square. 3 into minus 2 the whole square plus 1. Here you are having 6 into minus 2 minus 1. So it is 0. 2 into minus 2 is minus 4. Here 1. Minus 2 the whole square is 4, 0. Here minus 2 the whole square is 4, 4 3s are 12, 12 plus 1 is 13. And here you are having minus 1 is written as it is. 6 into minus 2 is minus 12, minus 12 minus 1 is minus 13. Here you are having 0. So you will get the determinant. Now you are going to find the value of the determinant. So the value can be determined by expanding any one row or any one column. Okay, so you by Laplace expansion using cofactors we are going to find the determinant. So R1 and R3, while you are expanding, you have to change the sign of the second element. And the same way C1 and C3, if you expand, using C1 and C3 if you expand, you have to change the sign of the second element. And R2 and C3, while you are expanding, you have to be careful with the sign, because you have to change the sign of two elements, first and the third element. So it is easy for you to expand by R1. Okay, you take we are going to find the value of the determinant by expanding by R1. Okay, so see that first you have to write the first element 0. What you have to do? You have to delete you have to find the cofactor. For that you have to delete the first row and first column. Okay, so what is remaining? You will have 4 entries that has to be written as a determinant, because cofactor is a signed minor. Minor is nothing but the determinant. So 0, 13, minus 13, 0. What I have said, while expanding by R1, you have to change the sign of the second one, because the cofactor sign here it is minus. So you have to change the sign of this. So minus of minus 4 is plus 4. I have written the second element by changing its sign. Then next what you have to do? You have to find the minor of it. So delete the first row and the second column. So what is remaining? 4, 13, minus 1, 0. These entries has to be written within the vertical lines. After the plus, you have to write the third element of R1. R1, that is 1. So 1 you have to write as it is. You have to delete the first row and the third column. Okay, the remaining entries has to be written within the vertical lines. So 4, 0, minus 1, minus 13. Okay, so here 0 into anything will become 0. So plus 4 into, how to find the value of the 2 by 2 determinant? You have to multiply the main diagonal elements. What is main diagonal elements? 4 into 0. So 4 into 0 is 0. In between you have to write minus. Then multiply the sub-diagonal elements. Minus 1 into 13 is minus 13. Okay, plus 1 into, what you have to do? Multiply the main diagonal elements. 4 into minus 13 is minus 52. In between you have to write minus. Then multiply these two. 0 into minus 1 is 0. So this element is 0. Here 0 minus of minus 13 is plus 13. So 4 into 13 plus 1 into minus 52. So 4 into 13 is 52. 52 minus 52, it is 0. So therefore the determinant value is equal to 0. So we are moving to the problem number 19. Determine the roots of the equation. So the determinant value is given as 0. So you see that the entries are written within the vertical line. So here you have written the value is equal to 0. You take this determinant which is equal to 0. This is the given result. So we have to find the value of the determinant. So by expanding here I have used R1. So while you are expanding R1 to find the determinant value, you have to change the sign of the second element. You see that R1. So the R1 first element is 1. So 1, what you have to do? You have to delete the first row and the first column. Okay. So the previous problem I have written these entries within the vertical line. Here in this problem I am going to expand directly. So it is a here 2 by 2 determinant is here. So what you have to do? You have to cross multiply the main diagonal elements. So it is minus 2 into 5x squared. So that is minus 10x squared. In between you have to write minus 2x into 5 is 10x. So see that 1 into minus 10x squared minus 2x into 5 is 10x. Directly I have written, I cut short the previous step, that is the entries has to be written 2 by 2 determinant. Okay, the first element is over. When you move to the second element, according to the cofactor, you have to change the sign. So here you are having plus 4, it has to be written as minus 4. Next, what you have to do? So you have to delete the first row and where 4 is present in the second column. Okay, so the first row and the second column has to be deleted. So what is remaining here? You are having 1515x squared. So you have to find the value of this 2 by 2 determinant. So you cross multiply the main diagonal 1 into 5x squared. So it is 5x squared. In between you have to write minus 1 into 5 is 5. Okay, second element is over. Next R1 third element. What is R1 third element? It is 20. Okay, you have to write plus 20. You should not change, you need not change the sign. Only you have to change the sign of the second element. Okay, so plus 20 into, what you have to do? Delete the first row because 20 is present in the first row. And which column has to be deleted? 20 is present in the third column. So it has to be deleted. Okay, what is remaining? You will have a 2 by 2 determinant having entries 1, minus 2, 1, 2x. How to find the value of it? So you have to cross multiply the main diagonal elements. So 1 into 2x is 2x. In between what you have to write? You have to write minus. So see that 1 into 2x is, here I have written 1 into 2x is 2x. In between I have to write minus, then multiply the subdiagonal elements. 1 into minus 2 is what? Minus 2. So minus into minus will become plus. So that's why I have written here it is 2x plus 2. So it is given, it is equal to 0. So equal to 0 is written in the right hand side. Now you have to expand the value. Minus 10x squared into 1 is minus 10x squared. And here minus 10x into 1 is minus 10x. So 5x squared into minus 4 is minus 20x squared. Minus 5 into minus 4 is plus 20. 2x into 20 is 40x. Plus 2 into 20 is 40 is equal to 0. So you group the terms of x squared. Minus 10x squared minus 20x squared is minus 30x squared. Next group the terms of x. Minus 10x plus 40x is plus 30x. And see the constant 20 plus 40 is 60. So it can be divided by minus 30. So you will get x squared minus x and minus 2 is equal to 0. It's a quadratic equation in terms of x. So you have to factorize. While you are taking the product, it should be minus 2 and the addition is minus 1. So we can write the factor as x plus 1 into x minus 2 is equal to 0. So x is equal to minus 1 and x is equal to 2. So we have found the roots of this equation. Okay, so we'll come to evaluation of a determinant of order 3 by using Sarrus rule. So up to which we have seen the evaluation of a determinant of order 3 by using Laplace expansion. That will be easy for you in 12th standard. We will use only the Laplace expansion. So now in your book it is given, Sarrus rule also is given. So if the name is mentioned, you have to use the method of Sarrus rule. So you should know about it. So A matrix whose order is 3, so it is a 3 by 3 square matrix is given. So first, Sarrus rule means you have to write the entries as follows. What you have to do? Take the first row entries A11, A12, A13. Again repeat A11, A12. The first two elements you have to repeat again. So in the same way, second row you take it, write it in order second. A21, A22, A23. Then repeat the first two elements of R2. That is A21, A22. The same way third row has to be completed. How it will be? A31, A32, A33. Then repeat the first two elements again. A31, A32. And you see that you have to multiply these three elements. So, and next these three elements. And next these three elements. So, you have to multiply. In between you have to write minus. So next in this order you have to multiply these three elements. So the main diagonal elements, so first has to be multiplied minus the sub-diagonal elements has to be multiplied. Then that is the value of the determinant. Okay, you see that one example is given. Example 7.17. Compute determinant A using Sarrus rule. So if the method is mentioned, you have to use the procedure of that. So A matrix is given. Okay, so A matrix we have taken. Okay, so we are going to use which rule? Sarrus rule. For that you have to arrange the entry first. So how you have to do? Take the first row. Take the first row. 3, 4, 1. Again you have to write 3 and 4. Take the second row, write like that, 0, minus 1, 2. Then repeat the first two elements again, 0, minus 1. The same way, third row, 5, minus 2, 6. Again, 5, minus 2. Next, what you have to do? You have to multiply the main diagonal. So, 3 into minus 1 into 6. 3 into minus 1 into 6. Next, plus 4 into 2 into 5. So, 4 into 2 into 5. Plus next main diagonal, that is minus 1 into 0 into minus 2. Okay, so here you don't have what is it, minus 1. Okay, so here you will have plus 1 only. Okay, so plus 1. So it is arrow mark, it is not minus 1, it is plus 1. So 1 into 0 into minus 2. Okay, so the main diagonal elements has to be multiplied. Next, in between you have to write minus. Then you have to multiply the sub-diagonal elements. What is it? 5 into minus 1 into 1. So 5 into minus 1 into 1 plus next minus 2 into 2 into 3. Minus 2 into 2 into 3 plus next one what it is? 6 into 0 into 4. 6 into 0 into 4. Where you have to calculate. 3 into minus 1 into 6 is minus 18 plus 5 into 2, 10, 10 into 4, 40. So here you are having 0. When you multiply with 0, the answer is 0. In between you have to write minus. In the same way, you have to multiply these elements. So 5 into minus 1 into 1 is minus 5. Next one, 2 minus 2 into 2 into 3. That is minus 12. And here you are having 0, so the element is 0. So here when you calculate it is 22. In between you are having minus. When you calculate these element it is minus 17. So minus of minus 17 is plus 17. So the determinant value is equal to 39. If the method is asked, evaluate or find the determinant value using Sarrus rule, in this way only you have to proceed. Otherwise, Laplace expansion is easy for us to find the value of the determinant. So using cofactors, we are going to find the value of the determinant in the Laplace expansion. So what you have to remember means, while you are expanding by R1, expanding by R3, expanding by C1 and expanding by C3, in the 4 expansion, you have to change the sign of the second element. Okay, using, while you are expanding by R2 and C2, you have to change the sign of the first and the third element. That is the important result in the Laplace expansion. But it is convenient for all of you to expand by R1 to find the determinant value. Thank you, students.